This question number one. If a equal to cos theta sine theta minus sine theta cos theta, then prove that a power n equal to cos n theta sine n theta minus sine n theta cos n theta. Let's consider the solution. So we are going to use principle of induction. So here, let's write n equal to 1. When we write n equal to 1, we get a power 1 or a equal to cos theta sine theta minus sine theta and cos theta, which is equal to a. So it's correct. We have got a from a power n. So now let's take n equal to 2. So when we write n equal to 2 here, we get a square equal to cos 2 theta sine 2 theta minus sine 2 theta cos 2 theta. Now, from here also we have to find out a square, and then we will check whether the two values are equal. So a square we evaluate by putting a into a. So cos theta sine theta minus sine theta and cos theta times cos theta minus sine theta sine theta and cos theta. Now we multiply. So we get a square equal to cos theta into cos theta cos square theta minus sine theta into sine theta will become sine square theta. So we will get first term cos square theta minus sine square theta. Now second term cos theta into sine theta plus sine theta into cos theta. So 2 sine theta cos theta. Here minus sine theta into cos theta and then cos theta into minus sine theta. So this will become minus 2 sine theta cos theta. And the last one minus sine square theta plus cos square theta. Which is equal to, this is formula of cos 2 theta, cos 2 theta. This is sine 2 theta. And this is minus sine 2 theta. And this is cos 2 theta. It means n equal to 2 is true. Now let's assume that a power k is true. That is, if a power k is true, it means we can write a power k equals cos k theta sine k theta minus sine k theta cos k theta. Now we have to prove that k plus 1 is also true. That is, so a k plus 1 means we are going to replace n by k plus 1 here. So it will become cos k plus 1 theta sine k plus 1 theta, then minus sine k plus 1 theta and cos k plus 1 theta. So let's prove it by multiplying a power k to a. So cos k theta sine k theta minus sine k theta cos k theta times a. A means cos theta sine theta minus sine theta and cos theta. So let's see. Now when we multiply, we will get a power k plus 1 equal to cos theta plus cos theta minus sin k theta sin theta. And second term will be cos k theta sin theta plus cos k theta sin theta plus sin k theta cos theta. Here we will get minus sin k theta cos theta and then minus cos k theta sin theta. And the last one will be minus sin k theta sin theta and plus cos k theta into cos theta. Clearly, this is formula cos A cos B minus sin A sin B, which is equal to cos A plus B. So it will become cos K plus 1 theta, and this will become, this is cos A sin B plus sin A cos B. So that's twice up. This is sin A plus B, that is here A will be K theta and B will be theta. So sin K plus 1 theta. And here, if we take minus sign outside, then again we will get sine k plus 1 theta. And this is cos A cos B minus sin A sin B, which is equal to cos A plus B. So this will become cos k plus 1 theta. So it means it is true for k plus 1 also. So we can say that it is true for all n. And this was our purpose. Thank you for watching.